Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily Leetcode challenge, I will show you 4 methods to do the same problem starting from O of n cube to O of n square to O of n and finally to O of 1. How your thinking process should evolve from brute force to the most optimal solution, you will get to know in this video. And if you like the video, then definitely do subscribe to my channel. It motivates me to put more effort in making the videos. So let's try to see the problem. We need to distribute candies among children. You are given two positive integers, n and limit. Return the total number of ways to distribute n candies among 3 children such that no children gets more than limit number of candies. Okay. So no children should get more than 2 candies in the first example as it is shown, and the sum of them must be 5. The sum of the 3 must always be 5. And the limit and n both are of the order of 1 is 6. Okay. So let's try to see the approaches one by one. So yeah, first can be a very brute force approach. So what you can do, you know that I, j and k, you can keep 3 variables and do just a brute force solution in 3 for loops. You can go from, you know that I can go from 1 to limit or n, whatever you can keep, and j can go the same. J can also go for the same, and the k can also go for the same. And if at the end for 3, at the end you just check that if I plus j plus k is equal to n, then you do count plus plus. Okay, this is a simple solution. This should come in your mind by looking at the problem in the first place. Another, which is also sort of brute force approach, if you try to think, this I, j and k, the sum of these I, j and k is always n, right? So if you know just 2 of them, I and j, you can definitely know k. So definitely, if you just iterate through 2 variables and you keep the sum of them, you subtract the sum of them from n, you will get k anyways. Okay. So what you can do is that you can go from I from 1 to limit. You can go from j to from 1 to limit. And what you can do is that you can subtract the sum of them from n. K has no other choice. In order to satisfy this criteria, k must definitely be n minus I minus j, as you can understand. Now you can keep a check whether it is greater than 0 or not, then only it is possible, right? So you can just keep a check and increment count. So this approach also you can understand. It is also quite a brute force approach. These two solutions should come in your mind in the first place. Now, how to optimize more? How should you optimize this to O of n square? N. Okay, if you think. So how you should think is that you were able to remove k. Can you remove j anyhow? So let's try to see. You need more manipulations to understand how exactly you can remove another variable. So you see, first of all, I plus j plus k is n. Okay. Now if you're thinking to do only one for loop, then you have all the possible choices for I. Okay, you do have all the possible choices for I. And also, you know, there is limit. I is less than equal to L, j is less than equal to some limit, k is also less than equal to some limit. Okay, you know it. So if you are iterating I, you know that j plus k has to be equal to n minus I. This has to be possible always. Okay, let it be sum. Now this j plus k value, from this inequality you can get that j plus k value must also be less than equal to 2l. Okay, so this j plus k value is nothing but s, right? So this n minus I or this s should be less than equal to 2l. So you can keep a for loop. You can go from for I 1 to L. Okay, you can go from I 1 to L, and you keep this n minus I. You check if n minus I is greater than 2L, then continue. You don't have any possible answers. Okay. Now, since now only two variables are there, whose j and k, whose sum you need to check whether it is s or not, what you can do, you can easily see that if j is 0, s is k should be s. If j is 1, k should be s minus 1. K has no other charge to become apart from this. J can go how much? Up to L. Then k should be up to s minus L. So how many possible values? You can just, if you can just, without iterating through these values, you just count how many possible values are there. Okay. So you see j has the maximum value, which what is the maximum possible value of j? It can go from minimum of limit. It cannot exceed limit. Okay. And it should not exceed the sum also, right? It should not exceed the sum. So like whichever is minimum, I will take that. Okay. You do understand this. Like if you are taking L, then it will be S minus L automatically K. But L should not exceed S. If L is exceeding S, then we take the minimum among those. What is J mean? You do understand that if K has the maximum value L, so you need to keep J within S minus L. If J is less than S minus L, if J becomes less than S minus L, then K will be greater than L and we will get a contradicting criteria. Therefore, J must always be greater than equal to S minus L. Okay. So minimum J can be S minus L. But you understand that this possible S is itself n minus I, right? It is possible that it may go below zero. Below zero, definitely Candies does not make sense. So you keep a zero max. Okay. This is all we need to do. Now you know how many ways can you go from, if you have a lower limit to have an upper limit, how many ways can you have lower plus upper, upper minus lower plus 1? You know that there are a number of ways. So you are counting, let's say from 5 to 10. You are seeing how many such numbers are there. All you have 5, 6, 7, 8, 9, 10. So these 6 numbers are there. How can you get that? 10 minus 5 plus 1. Okay. Similarly, you will do here j max minus j min plus 1. Okay. Now you know that since it is of the order of 1 is 6. Oh, and this is O of n time complexity. You are only iterating. Then definitely this is a possible solution. What you do, if it is not, if it is greater than 12, you just continue. Otherwise, you just add answer plus equals to this value. This value you just add in the answer. Okay. If you just add this, you see that O of n time complexity will work, and then hence this is a possible solution. So let's try to code it out. How would we code that? So you have n. Okay, so you have an iterating variable first of all, which goes from I equals to 0. It can take anything till the limit, and it's I plus plus. Okay. Now there should be an answer. Now answer should be long. Okay. Also you should take care that as I told you, what is the formula that I just derived? We need to see n minus I, right? We need to see n minus I should be equal to. So the remaining part, what is the remaining part? I will tell you is that n minus I. It is nothing but n minus I. Okay. If the remaining part is greater than 2 into limit, what you do? You just continue. You can do nothing. You just continue. You don't need to see the remaining part of the loop. You just continue with the next iteration. If otherwise, you have something to add to the answer, right? What you need to add? Lower limit and upper limit. Just calculate the lower limit as I told you. What was the lower limit? Lower limit was nothing but this max of S minus L and 0. Max of this remaining minus limit and 0. Okay, so this is like if you keep anything, if you keep j anything more than this, more than remaining minus l limit, then you will end up with more than limit candies, more than limit candies with k. Okay, so that's why this is the lower limit. If you keep anything less than, right, anything less than this, then the remaining portion must be covered by k. Yeah, so this is the lower limit. What is the upper limit? It is nothing but s minus l, right? As I calculated, max of not s minus l, minimum of limit and l. So what is the upper limit? It can go till limit, but you should see it is not alone consuming more than some, right? So it should be minimum of limit, comma, remaining. What you should do, you should add in the answer upper minus lower plus 1. Okay, and you can do is, all you can do is just return answer. Let's try to run this. So we do have the accepted. Let's try to submit it. Okay, so it gives the wrong answer. Why does it give it? Let's try to see. Here limit can be more than n. Okay, I'm traversing through limit. Limit can also be more than n, it is told, which is does not make any sense, by the way. But you do is iterate through the minimum among n and limit. So what you do, you just try to submit it once again. Yeah, so you see we do have the accepted thing, but the runtime complexity is not so much, because compared to others, because you can do it in O1 time also, right? So if you are quite good in permutations and combination, you can understand the O of one solution. So if you see a constant like 1 is 6, it is very okay with O of n solution. You do not need to understand the O of one solution. Okay, but definitely there should be some curiosity that if there exists some more optimal solution, you should definitely try to understand. So what is the more optimal solution? Now this approach, if you have not done permutations and combination properly in class 12 or so, you may find it difficult, but let's try. You have three variables, a, b, c, whose sum is n, and a is less than equal to l, b is less than equal to l, c is less than equal to l. Okay, you need to count everything by one, in order of one. Okay, in order of one, you just need to count. So you need a permutations and combination approach. So what can you do? You can count. So this can go from 0 to l. So you know number of whole solutions for this. Number of whole solutions means if a can go not in the limit, it can start from 0 to l, right? But if I tell that there is no such limit of l, a can go from anywhere 0 to n, then what will be the solution? It is a standard solution given by some combination. So let's try to see. If you don't know, so if a plus b plus c with no restrictions, how the solution is coming? You have n, let's say you have n candies. So you have n candies like this placed. You have n candies and you have two bars. You need to separate the candies. You have two bars. Let's say you have one bar here and one bar here. Okay. So you see this portion is the number of candies given by A. This portion is the number of candies given by B. This portion is the number of candies given by C. And you need to now how many objects you have? You have n objects plus two bars you have. These two bars also you have. Now, how can you arrange these bars? The first bar may come here, then 0, then second bar may come here. Okay. Again, another permutation can be like there can be one bar which is here, one bar again. no candies in between the bar. In this case, the B is 0. You can understand this, right? So you need to place n plus 2 objects. So, and some of them are identical to each other. So you know the solution is, if you know very basic PNC, the solution is n plus 2 factorial divided by n factorial and 2 factorial, right? This is how these are the similar objects placed. So this is nothing but n plus 2 C2. Okay. This is the total number of objects. If you can, based on no restrictions. Based on no restrictions, there are total number of objects is n plus 2 C2. So let me just remove this. So with no restrictions, you get n plus 2 C2 number of objects. Okay. Now what you can do is that subtract to get total number of methods. If you see, you can get no restrictions, you cannot have many restrictions, and then you subtract those cases with restrictions. Then you will have total valid, right? Total valid PN permutations. If you see, no restrictions minus with restriction. Okay. So you have this with restriction. So if you now with restriction, how can we say? So let's say the first child we give L plus 1 candies. Then we are violating our criteria, and then we try to approach it. Okay. So if you have seen the inclusion-exclusion principle, so it is something like it's A, B, and C. If you work with probability before, the probability of what is A union B union C is nothing but probability of A plus probability of B plus probability of C. Okay. Now this whole is the sum which you do minus, because you are counting these overlapping regions twice. You do minus of probability of A intersection B plus probability of B intersection C. Okay. Plus probability of A intersection C. Okay. And then again you have counted these overlapping case. Then you just alternate plus and minus. Okay. So probability of A intersection B intersections. This is the thing. If you have worked with probability this before, you must have learned this inclusion-exclusion principle, right? Now, how should we apply it here? As I told you, what you can do is give L plus 1 chocolates to the first child. Okay. How many remaining chocolates are there? N minus L plus 1. These are the remaining chocolates. How many ways can you distribute these remaining chocolates to all the 3 children? Okay. 1 children you give this, you have already violated that, but it is not restricted that you cannot give more than that, right? So if you see N minus L plus 1 plus 2 C2 is the number of ways you can give you can violate one child. Okay, at least one child violated, at least one child. Okay, but in these cases you have overlapped the ones with the 2 child. Then what you need to do, you need to subtract those. So you have counted something extra here, so you need to subtract the ones by giving at least 2 child L plus 1 chocolates. If you give 2 child L plus 1 chocolates, the number of chocolates remaining is this N minus 2 into L plus 1. So N minus 2 into L plus 1 plus 2C2 is the number of chocolates that you want to give. Now again, you need to add, you have also considered the case N minus 3 L plus 1 plus 2 C2. Okay. All the 3 child, you give L plus 1 chocolates. You have violated all the 3 childs, and then you do that. So whatever this thing you get, let it be sum. This sum is nothing but with restriction. So you can just replace this value of sum. So if you see the final output, if you want to just see the final expression of what will be the approach, thus final will be total valid will be total number of restrictions minus without restriction. So it will be like N minus L plus 1 plus 2C2 minus n minus 2 into L plus 1 plus 2C2 plus L minus 3 into L plus 1 plus 2C2. You also need to keep a check whether this is like reducing to less than 2 or not, because 1C2 does not make any sense, right? Choosing two objects from one object, zero object, or even negative objects. You should take care of these criteria. And you see, whatever is kc2 is always given by k into k plus 1, k minus 1 by 2. So I am not implementing this approach. You can always solve this. You just keep it, you just keep a function for calculating nc2, and you just feed into these values and direct return the values. It will be solved in O of 1 time. Okay, you can just check that out. I am not doing that. Just for your curiosity, I just told you all the approaches. So that was all for this video. This was definitely a medium kind of problem if you want to solve in O of n or O of 1. But I hope your day is going to be really easy. Thank you so much.